This video will review inscribed angles and the inscribed angle theorem. To begin, let's start by defining what inscribed angles are. Inscribed angles are any angle who has its vertex on the circle and whose sides intersect the circle. In this case, angle BAC is an inscribed angle because the vertex is located at point A, which is on circle. Now, when we start solving problems with inscribed angles, we'll use the inscribed angle theorem. And there's two ways to think of the inscribed angle theorem. It depends on what you're given and what you're looking for. In the first example on the bottom left, if I know the arc measure, for instance, the measure of arc BC, and I want to find the inscribed angle, angle BAC, I would use the fact that the inscribed angle is always half its intercepted arc. That means the measure of angle BAC is half its measure of arc BC. In the other case on the bottom right, if I know the inscribed angle and I want to find the intercepted arc, I would use the fact that the intercepted arc is twice as big as the inscribed angle. Now these formulas may look different, but they're really the same formula. It just depends on what you solve for. If I was to take the first formula, the measure of angle BAC equals half the measure of arc BC, and solve for that measure of arc BC by doubling both sides, I would get the second formula. So they may look differently, but it's still the same formula. It just depends on what you solve for. Now when you solve the problems in the next minute here, when we look at them, the piece that I'm going to use is based on what I'm given. So again, if I know the arc and I want the angle, I'd probably use the formula on the left. If I know the angle and I want the arc, I'd probably use the one on the right. It would just be easier. So let's look at some examples here. Take a look at the first problem, see what we're given, see what we're solving for, and see which formula you probably want to use. If you need to, rewind the video so that you know which way we're going to go, and try solving it. Pause the video, solve it out, and then check your answers. All right, hopefully you've had a chance to work these problems out, so let's check them. In the first problem, we are told that the measure of arc PR is 68 degrees, and we're looking for the angle. So in this case, I'm going to set up the idea that the inscribed angle, the measure of our angle PQR, is half the measure of its intercepted arc, half the measure of arc PR. If I then substitute, measure of angle PQR we're calling x, and we know that the measure of arc PR is 68 degrees. So by inscribed angle theorem, x is half of 68 degrees, or it's 34 degrees. In the second problem, it looks similar, except this time they've got the angle and the arc reversed. Here we know the inscribed angle is 42 degrees, and we're looking for the measure of arc PR. So this time I'm going to say that the measure of arc PR is twice the measure of that inscribed angle, twice the measure of angle PQR. And it's still by inscribed angle theorem. Substituting in what I know, we're calling the measure of arc PR x, and the angle measures 42 degrees. So 2 times 42 is 84 degrees. Now look at that last problem carefully. This time, again, we're looking for an inscribed angle, angle GHF, but they didn't give me any numbers. Now sometimes I have people come over and say, hey, this has got to be a typo, there's no numbers. No, you got to look at the problem a little bit more carefully. We have that segment GF. What kind of segment's GF? It's a diameter. And I know that a diameter cuts a circle in half, which means that segment or that arc GF would be 180 degrees because it's a semicircle. All right, we know over here is going to be 180 degrees. So even though they didn't give me this number, I know because it's a semicircle measures 180. And that semicircle has its starting and end points on the pieces of the angle GHF, which means angle GHF is the inscribed angle for that intercepted arc, which means it's going to be half of 180. Now we can use a special justification for this. I can just say that that's going to be the inscribed angle of a semicircle, and that half of 180 is always 90, which means the measure of angle GHF, which we're calling x, is an automatic 90 degrees. Anytime you see a problem like this where you see that diameter, which leads to a semicircle, and the inscribed angle is using that intercepted arc, which is the semicircle, it's an automatic inscribed angle of a semicircle is 90 degrees. All right, I hope these problems help, and thank you for watching this video.